Hello students, welcome to Law into Tech. Today we'll learn about how to find out the valency of the elements and also the electronic configurations of the elements. So here, first of all, here to find out the valency, here we have to know the electronic configurations and why actually the electronic configuration is doing that we have to know. As you know, first of all, these things we have to know. This is an atom. Okay, an atom consists of three subatomic particles. Okay, what are they? So they are protons, electrons, and neutrons. Okay, three subatomic particles are present. You know, according to the Maharishi and even by the Dalton's atomic theory, they say that atoms cannot be further divisibles. But further studied by the scientists, they found that atom consists of the three subatomic particles. What are they? The protons. Protons are the positively charged, electrons are negatively charged, and there is the neutron. What is that? Neutrons are neutrals. That means that no charge. Okay, so neither positive nor negative. And we have to understand that protons and neutrons are present inside this atom. So this is called as the nucleus. And found that electrons are revolving around the nucleus. So here, when these electrons revolve around the nucleus, they are revolving in such a way that they revolve in the different level of the energy cell. Okay, different energy cells. And these elements, you know that number of the protons, okay, in the previous videos and all, I already given the atomic number and atomic mass. The number of the protons is also equal to the number of electrons, as you know. Then this number of electrons is going to distribute in this different energy cell. And that distributions of that electrons in the different energy cell will be called as the electronic configurations. Okay, so electronic configurations we have to know. Other than only we can find out the valency of the elements. Yeah, okay. So, and in the ground is that the number of the protons and number of electrons. That means the atomic number is also equal to the number of the electrons. So, from the atomic number only, we are going to do the electronic configuration. Okay, so here, these electrons, when they revolve around the nucleus, they revolve in the different energy cells. Okay, so here, the energy cells. First of all, let me give you the this one. That is the electronic configurations. Okay, so here will comes the distributions of electrons in different energy cell, and that energy cell is called as the orbit. Around the nucleus is called electronic configurations. Okay, so that is called as the what are called electronic configurations. We have to know this one. Yeah. Sure. Okay, so by the Bohr was the scientist who explained about this one. Okay, exactly, correctly. And when these electrons are revolving around the nucleus in the different energy cells, okay, so they have the maximum number of electrons which can accommodate in it. Okay, so electronic configuration. Okay, so here we have to know the cell R, K, L, M, N. Okay, K elements, OP. Okay, so but generally up to the class 10 standard, K element, that is sufficient. Because the electronic configuration in the highest classes, that means in the class 11, 12 of the students, for them it will be a different electronic configuration. Okay, so this one. And here, the maximum number of electrons which can accommodate in different energy cell, that is orbits, okay, is given by formula, what is that? Twice n square, where n is the, what is that? Number of energy cell. That means that in which energy cells this cell belongs to, that is number of cells, okay, the number of the energy cells we can say. Okay, so this is the K, L, M, N. The K is the first cell, L is the second, M third, and 4. So let us find out the maximum number of electrons which can accommodate in it. Okay, so this is the electronic configurations and we are going to distribute. So to know the valency here, we have to know this one properly, otherwise so it will not be possible for us to understand this one. Okay, as I told you here, this is a nucleus, and around these different cells are here. So this is the first cell, K. This is L, this is M, and N. Okay, K cell is the first cell, L is second, this is third and fourth. Okay, so here cell, and here maximum number of electrons which can accommodate is here. The cell, the first cell is K. Okay, and we know that formula there is twice n squared. That is n means that is fast. This is the first cell. Okay, so 2 into 1 squared is 1, 1 into 2 is 2, it is 2. 2 electrons can accommodate in K cell. That is in the first cell, here 1, 2 electrons you can accommodate here. That's fine. And second cell is the L. Okay, so here there is a 2 into L, and value is 2, so 2 is square. 2 to the 4, 4 to the, that comes to 8 electrons. That means that in this L cell, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, maximum of the 8 electrons you can accommodate here. And like that, in the number third, that is M. M is the 2 into, that is the third cell, and value will be 3. Right, then 3 square. 3 square means not 3 into 2. Okay, it is a 3 into 3. 3 is a 9, 9 to the 18. That means that in this M cells, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 electrons can accommodate here. So that's fine. Okay, and like that, here in the number 4, that is the N cell. Here, that is 2 into, that is 4. 4 square is 4 is 16. 16 to the, that is 32. In the last N cell, there is the 32 number of electrons can accommodate in it. This is the maximum number of electrons which can accommodate. Okay, so, but what happened here, when we are filling the electrons for a particular element in different energy cell, what happens, first of all, we used to fill the lower energy level cells first. Okay, we cannot jump to the higher energy level to fill its electron. So we used to fill the lower energy cell first. After that, we will go to the higher energy levels. That means that before filling the K, you cannot go to the L or M. So first of all, you have to give for the K. After then, followed by the L. After then, the M and N. So like this, we have to fill. So, but what happened while filling these electrons? Okay, always times they tends to get stable configurations. Okay, so when an element becomes stable, when they have the 2 electrons, exceptions for some elements, or 8 electrons, 2 or 8 electrons in its atomic cell. If those elements whose are stable when they have 2 electrons in its atomic cell, they are just called as duplet configurations. And those elements which have the stable when they have the 8 electrons in its atomic cell, they are called as the octet configuration, octet. Okay, so always times either duplet or octet configuration, this element try to get this configuration. Why? Because they want to be more stable. Okay, when they get stable only, that means that they used to form the compound. So the combining capacity of an element, okay, that will be called as the what called the valency. Okay, the valency it will decide from its electron. That is the last cell से ही हम लोग क्या करेगा decide करेगा. So let us go for this one. Okay, so this point we have to know, and another point we have to know that while filling these electrons, here an element always times try to get its stable configuration only. Okay, so for example here, for the calcium has the atomic number 20. These atomic numbers and all you have to understand nicely. So I already given in my video. I mean in previous video I already uploaded there. You have to learn that one first. Okay, so atomic number of calcium is 20. And if we do the electronic configuration. Okay, electron configuration, electronic configuration you can write. Here, this is the K, L, M, and N. As we know that the maximum number of electrons which can accommodate in K is 2, L is 8, M is 18, and N also 32 as we know. But we have the 20 electrons. So, this 20 electrons is going to distribute to different energy cells. Okay, the maximum number of the electrons which can accommodate in K cell is how much? That is 2, right? So if you want to give the 1, no, it is not possible because you have the sufficient electrons, okay, to give to it. So you have to give. But if you give the 5 here, K will take? No, never. Because its capacity is only 2. It has the capacity of only 2. Okay, so that's why K will not take more than that's one. But if you have more, if you have the sufficient, then it will not take less also. It will take it exactly, that is 2. So like that, in the L also, L have the maximum capacity of 8. Okay, if you don't have, then you can give, but we have here 20, isn't it? So L also will take 8. If you have sufficient, it will not take more also, less also, exactly 8 will take. Then 2 8, that is already how much? That is 10 already. Out of 20, 10 already. Then do you think that this 18, that is M have the capacity 18, then you will think that, do you think that it will give 10? No. Okay, why? Because these M cells are very dangerous. Okay, why? They are very jiddi types. Okay, why? Because here they used to say that if you have 18, give me 18. If you have sufficient electrons to give me 18, then you give me 18. Otherwise, don't give me. You give me only 8. Okay, you give me only 8. If you have 18, give me, but otherwise, don't give me 10 also. I will not accept. Okay, and if you have sufficient electrons, then you give me, otherwise, you give me only 8. Okay, if you don't have the 8 also, less than 8 also chalega. That also I will take like that types. Why? They always try to get 8, because when they have 8 electrons in its atom cell, they become more and more stable. So all these elements, they try to become more stable. Why? To form the compounds. When they form the compound only, they become stable, you know. Okay, so stability होने के लिए कोशिश करते रहता है. That's we have to know. Okay, so it will not take 10, it will take 8. But suppose if you have the not more than 8 or less than 8 you have, then 5 also chalega, le hi jayega. But we have the sufficient, right? So we give the 8, then 18 already, then 2 remain, right? So 2 will give to the next. Okay, so that will give here. So this is the main criteria that you have to understand about the electronic configuration. Okay, they have the capacity of 18, but if you have, you will keep, but if you don't, then they will try to get the 8 or less if you don't have. Okay, if you have sufficient, then you will take 8. Okay, that's all the same thing. So this is how we can do the electronic configuration. Let us go for the electronic configurations of the other elements now. Okay. Okay, so we are going to find out the electronic configuration and along with its valency. So I will write the first 20 elements, the electronic configuration and its valency also. So let us learn. This is our main important topic that we are going to discuss today. Here, this is the atomic number. This is element. Here comes to electronic configuration, and here will come valency. And here we have to know that electronic configuration may K, L, M, and N will be here. Okay, so here only we are going to do the configuration. That means the distributions of the electrons will take place here. So first element here, you know, this is the first atomic number 1 is what? This is the hydrogen. Okay, I will not write all, just I can write the symbols, okay, because already given here. Okay, for first one I am writing here. Hydrogen has the 1 atomic number, then this atomic number is the number of the electron. I told you it is equal, right? So it will distribute to the fast cell, that is K, not L and M. Okay, so it will distribute to the K. Okay, and second one, this is what? This is helium. Okay, no problem. I write here helium. Its symbols is He only. Okay, next I will not write the name. Okay, I will write directly the symbols. Okay, so it has 2. Maximum K can get 2. Nah? So it is already given here. And number 3 is lithium, Li. So it have 3. So K will not take 3. It will take only 2. And the remaining one it will give to the L. So 1 will be here. And like that, number 4, that is beryllium. Beryllium is having 4, so here it will be 2 and remaining 2. Because K can take only the maximum of 2. So remaining will give till it is to 8. Okay, number 5 is boron. Here it comes to 2, 3, because 2 plus 3 is 5. Number 6 is what I call carbon. That is also 2, 4. Number 7 is the nitrogen. And here it comes to 2, 5. Okay, and number 8 is the oxygen. It comes to 2, 6. Okay, number 9 is fluorine. That comes to 2, 7. Okay, number 10 is the neon, Ne. Neon also coming here 2, 8. But it comes to 11, that is sodium, Na. That comes to 2, 8. How much it remains? That is 8. Okay, it also cannot take the more than 8. Told you before. Alright. So 1 remains, so it will give to the M cell. Yeah. So this is for the first 10 elements I am giving here. At the same time, let us learn about the valency. Okay. So the valency of the elements will be what? Okay, the valency of the elements. So hydrogen have the last cell how many electrons? 1 electrons it has, right? Then its valency will be 1. And for this helium, it has 2. That means that for this, you may be thinking that you will give 2. No, but its valency will be 0 because helium is a noble gas and it already got a stable configuration by getting 2. Already stable, right? So it either it will not lose or will not give. Okay, किसी को भी देगा नहीं, किसी से भी लेगा नहीं. That's fine. And for the lithium also having 1, so its valency also will be 1 because I told you from the last valence electrons will take. So it has 2, then its valency will be 2. It is 3. Okay, its valency will be 3. It is 4. It will be 4. Okay, but here it will get a minus. Okay, because it's non-metals. Okay, so and for the 5, what about this 5? You know, 5. If they have the 5 electron, then they will try to get a stable configuration when they become 8. Always time they try to become the 8 electrons in its outermost cell. So here, how much electron is required by these elements to become 8? That means 3 electrons, right? So its valency will be minus 3. Why minus? Because they will get this electron from others. If they take from others, if they accept electron, they possess the negative. Okay, yeah, and this 6 also it needs 2, so it minus 2, 7, that is minus 1. And what about 8? So it will be 0. Why? Because it is noble gas. Okay, so it will not give, it will not take from others also, it will not give. That's why its valency is 0. We take it as a noble gas. Or also, they are non-reactive elements. And the last one, this is sodium. So it's same with this one, it's coming. 1, it valence electron, then its valency also will be 1. Yeah, so this is for the first 10 elements valency along with the electronic configurations. The next elements is with the atomic number 12 is the what? That is the magnesium. Magnesium has 12 electrons, so it will have the 2, okay, 8.
Already 2, 8, there already 10. Then how many electrons remain? There is 2 remain. So it will be 2. So you see here, if last electron have how many electrons? It has the 2 electrons. Right. So it has the 2 electrons, then its valency also will be 2, as we discussed before. Alright. And the next is the aluminum. Aluminum also 2, 8. 2, 8 already 10, then it has 13, right? So L cannot take it will take electron only up to 8 only, not more than 8. Okay, so remaining one will give to here, then it's 3. Then it has 3, then its valency also will be 3. Alright, so last cell, that is the balance, this is called balance cell. Last cell is called balance cell, and balance cell may how many electrons are there, that we will check. If it has 3 valence electron, then its valency is 3. If it has 2 valencies. And now comes the silicon. Okay, silicon. So here it comes to 2, 8, and 4. Okay, so silicons will have the valency here 4. Okay, sure. It is also will be minus 4 here. Okay, yeah. And next comes to the what do you call after silicon, magnesium, aluminum, silicon, phosphorus. Why I write this one? Silicon Si. Okay, so phosphorus is P. We already learned about this one. Okay, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay, so already. So phosphorus, it has the 15 electrons. So 2, 8, and 5. Okay, I will do the configuration first and I will give you. Okay, sulfur is 2, this is for sulfur, 2, 8, 6 because it has 16. Chlorine also 2, 8, 7, and argon is 2, 8, 8. That means M cell में कितना electron आ रहे? That is the 8, right? That means that it becomes stable here. Alright, and next comes to the calcium, potassium. That is 2, 8. Do you think that it will give 9 here? No. Yes, you try to give it, but it will not take. Because the M cell says that if you have the 18, you give me 18. Otherwise, don't give me. I am more stable when I get 8 electrons in its outermost cell. So, it try to get only 8 electrons. And remaining one, just you give to my sister. That is 1, will give to the N. Okay. In the next, it will give the electrons. And the last one, what is that? The last one is what? That is the calcium. Calcium has atomic number 20, so here also will come 2, 8, 8. Last, it will comes 2. Okay, fine. So now let us comes about the valency now. Okay, it's about the valency here 5. 5 need how many electrons to become 8? That we have to know. 6, 7, 8 like before. So it needs 3 electrons, so its valency will be minus 3. Okay, and for this one, that is for the sulfur also 6, 7, 8. Its valency will be minus 2. And the chlorine is minus 1 because it has 7. And for this one, 8, 0. Why? Because they are stable. They already get stable. They will not give electrons to others also, and they will not gain electrons from others also. That's why they already get stable, so its valency will be 0. Okay, fine. Yeah. So, and the next down here comes to the just 1. As we learn here, if you have the 1, then their valency will be 1. If it has 2, their valency will be 2. Okay, so this is all about electronic configurations. And you have to keep in mind that what main important point you have to understand, those elements which have 1, 2, 3, okay, valence electrons, they are metals. And 4, they are exceptionally for carbon, it is the non-metals, okay, and the others remaining, those which have the 4 electrons, they are metalloids. They are generally semi-metal, or you say metalloid we call, okay. And those elements which have what we call 5, 6, 7 valence electrons, 5, 6 valence electron, and in the valency में minus लगाया जाता है ना, okay, minus 3, minus 2, minus 1, they are non-metals. Okay, so this point also you have to understand. Okay, so you finish this one, and just I will give you these tips here. Valence electrons. Okay, valence electron, that is the last cell. Okay, that means that last cell where the electrons enter. We have to know, okay? So if the valence electrons have 1, 2, 3, okay? And here also 4, 5, 6, 7, 8, as we know. Valence electron maybe 1, 2, 3, 4, 5, 6, 7, 8, right? Then here what happened? Those elements which have the valence electron 1, 2, and 3, okay? 1, 2, and 3, okay? They are metals, okay? They are metals, we have to know, okay? And after losing electron, they will possess positive charge, okay? After giving electron to others, they become positive. And this is the number 4, okay? 4. It is also actually non-metals, as carbon is a non-metal, as we know. But some other elements, they are what they call the semi-metals, okay? Or you say metalloid, okay? So for these 4, they are non-metal also, metalloid also, okay? Say, and you say the semi-metals, better. Semi-metals, or you say the metalloids, okay? And those which have the 5, 6, and 7, okay? 5, 6, and 7, they are what? So they are non-metals, okay? And those which have the 8, they are what they call noble gas, okay? They are so noble, so humble that they do not react with any elements. Okay, and here will come the exception, except for helium. Okay, exceptions for helium. Okay, so helium का तो क्या होगा? उसका valency 0 होगा ना? Noble gases का valency भी 0 होता है, right? So this point, these tips also you have to understand. Okay, metal they will lose electron and they will call as the metal. They are metal and they are called as the electropositive. They are also called as electropositive because they can lose the electron and they become positive. And non-metals, they are also known as the electronegative because they have a tendency to lose electrons. No, really? No, to gain electrons from other. Okay, after gaining electron, then they become negative, right? So they are called electronegative and they are called electropositive elements. Okay, fine. So this is all about these electronic configurations you have to know. And the next videos and the next class and all, we will discuss about how to write the formula of the compound. Thank you.